So this is a lecture about arrays. Now, arrays are really flexible data structures. It exists in almost every language in some form. It allows us to group a bunch of data into one memory unit that we can access easily. And they are very easy to manipulate. So arrays are very popular data structures. They are linear. That's a group of bytes that are together with some properties. So let's talk about what the arrays are and the array properties. Now, first of all, when you think of an array is like a block of memory that's been allocated so that it can be segmented into some bytes of memory. Like, for example, you can think of this as an array of integers where each of these blocks is 32 bits. So we can say each of these blocks is 32 bits or 4 bytes. So we have a total of 5 spaces here. That would take a total of 20 bytes. So when you allocate this memory, when you allocate this array, you need to find a memory block of 20 bytes from wherever this memory is coming from. I will talk about that in a little bit. Now we also have a reference to an array which allows us to access the elements on this array using the index operator. So A's of 0, A bracket 0 meaning A bracket 0, that's the array element 0, array element 1, array element 2, and so on. Now you can also notice that the array indices vary from 0 to n minus 1, where n is the length of the array. Now there are a few properties of arrays that we should know about. One, the array is a contiguous block of memory. So in other words, when you request an array, you have to find, the compiler has to find and allocate a contiguous block of memory for this array. So if you ask for an array of million integers, you would need 4 million bytes. That's about 4 megabytes of memory in one place. So we have to be very careful about allocating memory for arrays, for large arrays. Number 2, the array elements are what we call homogeneous. So we can say it's an array of integers, or array of booleans, array of any other type that we define. So the arrays are homogeneous. The third property is called the arrays are random access elements. So although you can think of this as an array of 5 things and array of 5 variables, you can access them immediately. Like, for example, if you want to access the 4th element of this array or the last element, you can quickly access it. And we do know where this element is, or we do know what we call the address of A bracket 4. We should be able to compute that very quickly in order to assign the byte pattern of that location, the next 4 bytes of that location given by A bracket 4 to the byte pattern of 20. Now, arrays in Python. Arrays in Python are really lists, and you can define an array like a list. An array is a list, and Java think about array as a list. It's part of a list interface. And so Python also has arrays, for those who are coming from Python. Java has arrays, and Java arrays are defined with what's called the new construct. What the new does is it allocates memory for the array. So here's an array of 12 things, which means that you would be allocating 48 bytes total for this block of memory that is contiguous, and it's segmented into 4 byte blocks. And the indices go from 0 to 11. Arrays in C are somewhat similar to the arrays in C. Note, in this case, the arrays in C, you have allocated memory for 5 integers here, and you have initialized them to 5 things. 1, 2, 3, 4, and 5. And these places are indexed by A's of 0, A's of 1, A's of 2, and so on. So 3 and A's of 4. Now, one of the problems with C is that, but this is one of the reasons that we try to keep our C note arrays bounded, is that A5 does not exist. Although A5 does not exist, it's possible in C that you can allocate something to that location. So in other words, although I have only allocated 20 bytes for this array, 20 bytes, 5 integers, each one is like 4 bytes, but I can still go over that and write into an illegal memory location. What I mean by illegal is that I did not claim it. It might belong to someone else, but I still can write it. So that's one of the C's vulnerabilities of using C, and you will know that as we go through the course. Now, arrays in C note are of this type. Like, for example, you can say array integer array A is defined as an array of integers. So a value of this type is a reference. So when we define this, what we are saying is that A is some reference to some memory address, although we haven't allocated the memory yet. And when we allocate memory of size n, the length of the n is determined at the type of allocation, and intrinsic length n determined at the type of the allocation, and the array references can be referred from A0 through AN-1. Now this is a declaration only in C note, so that's a declaration, but I have not allocated any memory for this array. Now, so how do we allocate memory for the array? We allocate memory for the array using a function, a library function in C called alloc_array. Now alloc_array has two things. One is the type, and this is an expression that will be evaluated to something that I can compute. So for example, if I want to allocate an array of 5 integers in C note, I would be saying this something like this: alloc_array of int and the number of elements in the array that I need is equal to 5. Now there are a few things that are important here. One is that as you allocate the memory, you define the type of the element that the array can hold. So unlike in C arrays, we cannot write something other than an integer into this array. It also tells us that there's only 5 things in this array, and this array is bounded. In other words, it's not possible to access A's of 5 and allocate some element into that. So this is okay in C, but not okay in C note. So that's one of the reasons that C note is what we call type safe. And when you define a type, an array type, we must define what type it is and how big the array is going to be. Now we'll talk more about these things later, but this alloc_array allocates 20 bytes of memory from a place called heap. Now this is how the RAM is organized typically, and I will go into more details. The operating system, the stack, and the heap, and the read-write data, and the read-only data, and the program, they all live in the space. So all of these things take space, but we'll talk about those things as we go. But for now, what we need to do is that 20 bytes of memory needs to be allocated from the heap. Now arrays have what we call the L values. That means L value is a reference to an object stored in the memory. That's the definition of an L value. So for example, if you say A's of 2 is equal to 10, what we mean by that is this is the reference really to A's of 2. Now speaking C, this would translate into something like this. It would take the address, the location of A, add 8 bytes to it. You will know why when we talk about C, and then what we call dereferencing it, and then allocate, assign that to 10. So this is in C. Now in C it's kind of clear what we're doing, but here it's not really clear. Here it seems like that A bracket 2 gives you some reference to the location where the A of 2 is pointing to. So A bracket 2, you can think of A2 being 10 here. Now array invariance. Now what does remain constant in an array? The length of the array is supposed to be constant in C note, what we call static. Okay, C note arrays are bounded to be type safe, and C arrays are unbounded. That's one of the things you want to know. And then in C note language, you are provided with the dash length of an array that can be used only as a contract. It cannot be used as an it cannot be used as an attribute. So for example, you cannot say for equals 0 to length. Cannot say that, but we can use this in a contract to test the sizes of the array. Now let's think about something like a function that we want to write using an array. Let's say that you're given an array called A of size n, and we like to write a function called double the array. And we must copy all the elements in the old array into the new array. And then we have to return an array of integers back to the calling program. So let's write some preconditions. Now what does this require? This requires that n to be perhaps greater than or equal to 0. If n equals 0, we know that that array is empty, or it's just a empty array, or don't have anything in there. Okay, we'll talk about those things in detail. But what we ensure, what our first condition is what? Whatever the result, if you take the result of this function, and if you find the result, which is supposed to be an integer array, and if you find the length of this result, that's supposed to be equal to the 2 times the length of that was passed to the function. So how do we do that? We can simply write a piece of code like this. Let's start with a definition inside a local definition inside the function. Let's say b is an array of integers, and we're going to allocate an array using alloc array of integers of size 2 times n. And then once we allocate memory, we can write a for loop for int I equals 0, I less than n, I plus plus, and we do write the following. We just say b of I is assigned a of I. Now we do know that b of I is twice as long as a. So what happens to the other elements? In fact, they do become, by default, they do become 0. At the end of this loop, we're going to be returning the array b. So what we are really returning is a pointer to this array that was allocated. So although b will disappear at some point, but the reference to b was passed back to the main program. We'll talk more about this in class tomorrow. So this is going to give you what you need. Now you can write some loop invariances here. So one of the possible loop invariances that you can write inside this is that I is greater than or equal to 0 and I is less than or equal to n. It's possibly a loop invariant. Maybe we can try to prove that. Okay, so let's keep going. Here's another example of an array where we have an array called cubes. What it does is to allocate an array of n integers and initialize each of the array into the cube. So 0 cubed, so you would get an array if the n is going to be, let's assume that n is going to be 2. So you will get cubes in this array. If n is 2, then you're going to get 0 and 1, so you're just going to get 0 and 1. If n is 3, you're going to get the first 3 cubes. That would be 0, 1, 8. If n is 4, you're going to get the first 4 cubes. That's going to be 0, 1, 8, 16. Actually, that's not 16, right? 3 2 a cube, that's going to be 27, and so on. Now we can assert that after you exit the loop, the x is equal to n, and we can prove that this is a loop invariant. With the loop termination condition, we can also prove that the assertion is x is equal to n, and so on. We also ensure that the length of the result, because the result is an array, the length of the result is going to be n. We want to make sure that we have n elements. If n equals 4, we have 4 elements in this array returning. Array operations. We can search an array using what's called a linear search. Linear search starts with the 0th element. You have a target that you're looking for. Let's say you're looking for this, and you're going to be looking at 0, then you're going to be looking at 1, you're going to be looking at 2 until you find or not find this thing. And we'll talk more about these things in the lecture next week about this linear search. So search is one of the simple operations in an array. We can copy arrays. That's very important. Like for example, we have 2 ideas here. One is called a deep copy and the other one is called a shallow copy. Now the deep copy means that if you have an array A, you make exactly the identical copy called B, where when you change B, if you say b of 5 is equal to 10, it changes the b, but it does not change the a. So a of 5 still remains -1. Now if you have a shallow copy, which means that the new element array is just a pointer, which we do by saying int bracket b is assigned a, and then we don't change, if you change b, for example, if you say b of 5 is equal to 10, that also implies, well, we don't have b of 5 in this case, let's say make it b of 4 equals 10, this also implies that a of 4 equals 10. So whatever you do to b, or the alias, we call this the alias, will affect the a. And so this is at the end of the lecture, the short lecture, and I will talk more about this in detail in class tomorrow.